When sun hits your skin, normally what happens is it makes damage to your DNA in a millionth of a second. And what we found out is that in melanocytes, which are the cells that make the pigment that's protecting your skin, that's not all that's going on. What happens is you're getting the same kinds of DNA damage in your skin for hours after the sunlight exposure is ended. We've known for a long time that people who have blonde or red hair are more sensitive to sunlight, for sunburns or skin cancer. But you could say, well, maybe that's because they have light skin. So what's a surprise here is that melanin is actually doing things that can cause cancer as well as prevent it. What's happening is that sunlight hits the skin and it turns on a couple of enzymes that make a couple of chemicals that react with each other, and then they excite an electron in melanin. And that sort of thing's never been seen before in mammals. It's the same sort of reaction that happens in fireflies, but it's different here. And then after that, the electron has very high energy. It transfers that energy to DNA and makes DNA damage of the kind that can cause skin cancer. Because this is slow and takes several hours, it actually gives us an opportunity to jump in and intervene. So you can imagine designing chemicals that dissipate that energy before it has a chance to get to the DNA. And in fact, there are chemicals like that that exist, and we use some of those in the research as tools to find out what was happening. But you can imagine getting better ones that would be practical to use in skin. So our understanding has been that, well, you put on sunscreen before you go out into the sun, and that protects your skin. Here, you've got a different situation where what you want to do is add something after you leave the beach or after you leave the tanning bed, and it protects you for several hours after.